if cos theta equals to root 3 over 2 and tan theta is negative, find sin theta. So cos theta equals to root 3 over 2 and tan theta equals negative, find sin theta. I want you to know first of all that anytime cos is equals to root 3 over 2, sine is equals to half. And anytime sine is equals to half, anytime sin theta equals to half, cos theta is equals to root 3 over 2. And then anytime cos theta, this and this, they are the same thing. So anytime I'm supposed to say anytime cos theta equals to half, sin theta is equals to root 3 over 2. You need to note this. Also, anytime sin theta equals to 0, cos theta equals to 1. And anytime sin theta equals to 1, cos theta equals to 0. This is coming from the fact that sin theta is equals to cos 90 minus theta, and cos theta is equals to sin 90 minus theta. So since I have here root 3 over 2, it simply means that sin theta is going to be half. So sin theta is going to be half. But I need to now check something. In the first quadrant, all of them are positive. Yes. In the second quadrant, sine is positive. In the third quadrant, tan is positive. And you need to know that if sine is the only one positive here, cos is negative, tan is negative. Here, tan is positive, sine is negative, cos is negative. Here, cos is positive. And notice that what they gave us here, cos is positive. So where is tan negative is in this quadrant. This is where tan is negative, cos is positive, sine is negative. So which means that if we are finding sin theta, since we know that anytime cos is root 3 over 2, sine is always going to be half. So this means that sin theta is going to be equals to negative 1 over 2 is in the fourth quadrant. And that means that sin theta itself is going to be, you know that in this first quadrant, half, sin 30 is half. Here, sin 150 is half, positive. But here, sin 210 is negative. And here, sin 330 is negative. So this theta should be sin 330. This should be theta should be equals to 330 in the first quadrant, in the fourth quadrant. So how did I find out? I did where do I have cos positive and tan negative? It's in the fourth quadrant. That means the sin theta there is negative. So if you want to do this where maybe you don't want to use this my approach, if you want to do it by calculation, you say sin theta equals to minus half theta equals to sine inverse minus 1 over 2. So if you do it, it should give you theta equals to 30. Let me punch, I'm coming. So theta equals to 330 degrees. So you get theta equals to minus 30 degrees. And minus 30 degrees in the fourth quadrant is equals to 330 degrees. So go and check my video when we started. The next one, they said given that tan theta equals to 1 and minus 360 is less than theta and less than 360, or you say theta is an element that is below, that is above minus negative 360 and less than 360, give 4 possible values of theta. So when tan theta equals to 1, so look at the question. Let me write it. Question 21. I said tan theta equals to 1, and that theta is above minus 360 degrees, or falls in the range of minus 360 degrees and less than 360, or within 360 degrees. So they said I should give 4 possible values for theta. So for me to give 4 possible values of this theta, I'll say tan theta is equals to 1. So when tan theta is equals to 1, how do I find theta? Theta will be equals to tan inverse of 1. Tan inverse of 1. So tan inverse of 1 will be equals to 45 degrees. So if I know this, so tan inverse of 1 is 45 degrees. That means theta is 45 degrees here. So what I will ask myself is, the 4 possible values of theta will simply be this way, this way, this way, and this way. This line has a parallel line this way. This line has a parallel line this way. This line has a parallel line this way. I want to make it separate. And this line has a parallel line this way. Then the acute angle, I told you that the angles will always be less than 90 for these quadrants. So if I know this, in the first quadrant is 45 degrees. The second quadrant is going to be 90 plus 45, which is 135 degrees. So it's still 45 degrees, but because it's in the second quadrant, you are now moving from here to this point. See it? Because that is what positive angle is when you're going from anti-clockwise. So 90 plus 45, 135 degrees right here. See here, 135 degrees. Yes, 90 plus 5. Remember, if you do it by this way, if you want to take just this one, what you're doing is still the same first quadrant, 45 degrees. But if you check the opening, this is 135 degrees. So that is why 135. Now, if you do 135 degrees now, for this particular one, all you just do is to say, okay, you now have 180. If you do 180 minus 135, for example, you see that what you have here is 45 degrees. 45 degrees. So since I have here to be 180 degrees, 180 plus 45, 180 plus 45 degrees, 225. So this angle up to this place is 225 degrees. Then in the fourth quadrant, remember I told you, in the first quadrant, half equals to the theta you are given. The second quadrant, half equals to 180 minus theta. Or you say 180 theta equals to 180 plus alpha, which is what I did. 180 plus 45, I got this. Now in the third, this is second quadrant, this is third quadrant. In the third quadrant, you have theta equals to 180 plus alpha, or theta minus 180. That is why if you do 225 minus 180 here, 225 minus 180, you get that the angle here is 45 degrees. But if you run it from the origin, see that you are adding. You need to go and check my first video so you understand better. Then the fourth quadrant is going to be 360 minus theta. And alpha is equals to 360 minus theta. So notice something. If I'm moving this way now, I've gotten 225. So by the time I come to this place and do 360 minus 45 degrees, 315. So this theta, remember in the first quadrant is theta, the second quadrant in the second quadrant, you are doing, yes, this is first quadrant, second, third, fourth. How to get it? So I'll do 360 minus 45 half equals to 315 degrees. So that means that if I start from here, this origin now, go around, that what I have here, everything here, it's 315 degrees. And notice that 315 degrees and 45 degrees, they are the same thing here, but just that this side, it might be negative, it might be positive, depending on what quadrant you are looking for. So if that be the case, the four possible values of theta will be equals to, theta is equals to, okay, let's do it this way. So theta is equals to 45 degrees, 225 degrees, 315 degrees, 45 degrees in the first quadrant, 135 degrees in the second quadrant, 135 degrees. So by the time you do sine 45 and sine 135, for example, it will always give you positive, while sine 225 and sine 315 will always give you negative, because sine is negative in the third and fourth quadrant. But as for the angle, this is how to find the angles, to find when it's the same. So for example, let's do it. Sine 135 is 0.7071. Then sine 45, the same thing. Now sine 225, the negative, and sine 315, the same thing but negative. So you need to know that. So if you do it for cos and tan, you will still get the same thing, 2 positive, 2 negative. So, and they will be obeying the areas where cos is positive in the quadrants and where it is negative in the quadrants. So this is how to find out angles. So let's move to the next question. They said an acute angle has an associated acute angle of 50 degrees. An angle theta has an associated acute angle of 50 degrees. Find sine theta. So they said an angle theta has an associated acute angle of 50 degrees. Find sine theta. So let's say this is the acute angle. This thing for acute angle, you see, it has 50 degrees. So in the first quadrant, you don't have to subtract anything. But in the second quadrant, what you can just do is to say, okay, if I'm finding sine theta, theta in the first and second quadrant is positive. In the third and fourth quadrant is negative. So if you do it this way, you will still be correct. So I can just say, let me punch sine 50 first without being practical. Let's use calculator for exam's sake if we need to be fast. So let's do sine 50 is 0.7660. So in the first and second quadrant, sine is always positive. If you remember, E, S, all of them are positive, all the three ratios. Sine in the second. So in the third is negative, only tan is positive, only cos is negative in the fourth. So that means this will be negative 0.70660, negative 0.7660 in the third, fourth. While here it's going to be positive in the second and first. But if you don't want to do it like this, to be sure of your answer, you can say if this is the acute angle here, and this is the acute angle, which means that every angle they tell you to find, you need to be always putting it in mind that you need to find 4 angles where 2 is positive and 2 is negative. But notice that you cannot have 50 here, so which means that the angle right here for second quadrant, if I have this to be 50 degrees, I will say if this is 50 degrees, from here to here is 90, shebi? So, and from here to here is also 90. 90 minus 50 is 40. Now, this 90 that I have here plus 40 is 130. So, the angle from here to here is 130, which means that 130 degrees is equals to 50 degrees. 130 degrees is equals to 50 degrees. How do I know that? You can see that 50 plus 30 is 180. Remember that I once told you that 180 minus theta is equals to any angle you find is equals to alpha here. So if that be the case, if I have, for example, sine 180 minus theta is the same thing as sine theta, whatever I have. So if that be the case, if for example I do sine 130 and sine 130 will give me the same thing with sine 50. So in the second quadrant, this angle is 130. The second quadrant, that is 130. So 130 is the same thing with 50 degrees. So in the second quadrant, using alpha equals to 180 minus theta. So alpha is equals to 180 minus 50, which is equals to 130 degrees. So second quadrant. So if you punch sine 130, it will still give you positive 0.7660. While in the third quadrant, if this is the angle, remember I told you that the angle here will always be acute angle. If this is the angle, notice that everything here is 180. And I give you some formulas. I told you that in the third quadrant, alpha is equals to theta minus 180 degrees, or theta is equals to 180 degrees plus acute angle, alpha. So for example, if I know this, if this is 180 plus 50 is 230. And if you do 230, that is theta, and 230 minus 180, you will get 50 degrees. So 180 plus 50 is 230. 180 plus 50 is 230. And if you do 230 minus 180, you get 15 degrees. So 230 is our angle here, which means that everything from here to here is what you calculate in the third quadrant. So in the third quadrant, this is 230 degrees. So theta equals to 230 degrees, which means that if you do sine 230, you get theta equals to negative 0.7660, which is what we got here in the third quadrant. So if you want to be sure of your answer, you do it this way I'm doing it. But if you don't want to stress doing this, you just remember this one. Then in the fourth quadrant, remember that here is 50 degrees. So if here is 50 degrees, remember everything from here to here now, fourth quadrant will be 360. Alpha is equal to 360 minus theta. So 360 minus 15 degrees going to be 310 degrees. 310 degrees. So which means that everything from here to here is 310. From here to here is 310. So 310 degrees is equals to 50 degrees, because this angle here will be minus 50 degrees. This angle means minus when it's sine. When it's sine, this angle means minus. But let me not put it here because I can do cos if possible. So let's check it. So if that be the case, if I do what I'm supposed to do here, if I'm not obeying that sign of putting negative, what I will do here is sine 310 degrees, which is going to give me negative 0.7660. So I believe you understand. If you understand this. So let's do sine 310 degrees. So that's in the negative. So with that said, let's do, okay, they said I should do a graph of this. I'll solve this one in our next class, but for now I want to solve the mathematical aspects. And they said the relationship that exists between the various circular functions is known as standard identities. Standard identities. Now, let me solve this one. So, they said under solutions of trig equations, solve within the range 0 degrees less than or equals to x less than or equals to 360 degrees. The equation sine x plus 3. So the equation sine x plus 3 sine x cos x equals to 0. Question 24. Let's quickly do that. So they are telling us that x is less than or equals to 0 and less than or equals to 360 degrees. All those things are just telling you a range that your theta or your